What's up? So, starting along, coming back at ya. Oh, there we go. I'm gonna mute myself. Boom. Alright, strivers, let's go. I wanted to just start streaming more often, especially with my good friend Amir. So, I'm gonna start streaming with him much more often to build a fun project that I thought of and that he was willing to hop on board with. So I'm pretty excited about that. Here, let's pull up my beautiful face. There we go. Boom. Yeah, that's better, right? So just some introduction. Like, I wanted to talk about why programmers are better than you. And I mean, if you are a programmer, hopefully what I talk about makes complete sense and maybe provides a bit of clarity for you and why that makes you awesome as an individual and capable of really problem solving far beyond kind of what your average Joe is able to do. Someone who doesn't have any experience with programming. I mean, I also wanted to be kind of controversial with the title just because, you know, why not? It's kind of fun. So why programmers are better than you. So let's get started. Let's just give you some examples. And I'm also testing out this software from Apple, the Freeform thing, whatever it's called. And let's jump into reason number one of why programmers are better than you. Reason number one is they have clarity on how to break a problem down in such a minute manner that they can communicate it effectively to a computer. Right? Computers do exactly what we tell them to do. There are rules, there are laws that govern their functionality. They might bug out occasionally, but generally that's our fault, right? And when we are programming, we are taking problems, breaking them into pieces of information that are valuable, determining what pieces of information are valuable, and then we are from there building things that are of value. And hopefully, you know, that entire spiel made sense. But let's look at some examples. So, and as per usual, my laptop starts lagging when I stream with OBS. I feel like I need a better laptop, man. So we're gonna start with a square. Boom, we've got a square. Can I type in the square? I can type in the square. All right. So programming is effectively, I'll say, the process of programming looks like this. We receive a project that needs to be built. And when we receive a project that needs to be built, we break it out into two main things. First and foremost, we begin defining our vocabulary. And I would say that any individual, any programmer who cannot define or does not define the vocabulary of the project that they are working with, it's like they're immediately shooting themselves in the foot, because even in their own brain, they will not be able to succinctly describe to themselves the problem they're working on and the solution they are trying to create for it. And so with every new project and every new field, every new domain, there's always going to be new ideas. And those new ideas generally need definitions, need vocabulary to describe them. And this becomes increasingly true the more complex your project gets. It really sucks when you have collisions between vocab words, because then you have to have context. And when you're programming, right, It's pretty easy to have context in a conversation. It's much harder to build that context into a computer because, well, computers are not very, they don't pick up on context unless we provide all of the context. So having solid vocabulary and definitions of those is kind of our first step as a programmer, even if you do it subconsciously, to solving the problem. It's like, I need to first understand what you're trying to tell me. And if I do not understand it, I cannot help you. And the first step to understanding it is defining the vocabulary that is used to describe the problem. So that's our step one, is defining vocab. And I cannot state like how important this is. I feel like so many developers miss this, don't do it, and they do shoot themselves in the foot. Hardcore, man. They shoot themselves in the foot so hard when they don't do this. But this is why programmers are better than you. So, well, maybe I should say good programmers or great programmers. But this is the system that I go through. And honestly, this is the system that I just call, like, it's like I'm seeking clarity, right? My goal is to seek clarity. If I receive a new project, I'm working in a project, I'm breaking down a problem, my goal is always, I'm seeking clarity. And the number one way I do that is by defining vocabulary. And if I can't list out the words that I'm using and clearly describe them to myself or to another individual or, to my baby child, who is now my rubber duck, then I'm going to fail. The next thing is we need to define our systems. And another way that you can describe this is we have our, I just call this the flow of information, right? Programmers are incredibly good at seeing and understanding and structuring information and how it moves from point A to point B. I would argue that all of programming is literally this, the flow of information. One of the reasons we defined our vocabulary is because we wanted to create the data structures. With our vocabulary in place, we know roughly more about the data that we need to track as a developer to solve the problem, right? So, like, for example, if I'm building a global supply chain software that is meant to track information and inputs from factories across the globe, there's going to be a lot of information that I'm going to need to track. So, like, the time a purchase order was sent, who the purchase order was assigned to, which factory is fulfilling it, or potentially factories. And so we have multiple factories that are assigned and fulfilling an individual PO, and so we have that relationship between the two. But we've defined this vocabulary, right? Factory. What is a factory? It's a physical place that creates goods. Okay, well, what's a good? So you have to get really granular because you're going to be designing a system, a piece of software that the computer will actually solve the problem for. I don't think that sentence made sense, so I'm going to restate it. By getting that granular, by getting that clear, you are actually able to design the software that will solve the problem of the client. And at the end of the day, that's the goal. That's it. That's our purpose. That's what we're trying to do. Solve the problem of the client. We might be the client, right? So by defining our vocabulary, we are defining the data to track, right? And I'm going to give this a different color because, why not? Let's do red. Boom, defining the data to track. And I might say data or information to track. So then we define our systems. And I mean, once we have our vocabulary, once we have our structure of data, then we begin defining our systems. And I'll say that this is the flow of that information. So what's important about this is that the flow of information is basically, okay, it's broken into three main things. First and foremost, it's triggers. Something has to happen. I call them triggers. You might also call them events. Zapier, I think, is a great example of, just flow a system, right? It defines when you're working with Zapier, and if you don't know what Zapier is they call it the glue of the internet, I think. You're able to create automations that trigger when an event occurs and that executes different actions that you wish to happen when that event occurs. I'm going to say every single time the Zapier event occurs, I'm going to say that data is either created or transformed in some way, shape, or form. So when the event occurs, you're either logging that it occurred, or you are transforming information now into another medium and doing something with it. And that process is what I call the flow of information. So just breaking it out into the three pieces that I just described there, we've got our trigger, or the event. Then we've got our, I call it like the, what did I say? The data creation, or, whoops, that's up, or data manipulation. Honestly, it could be both of these, right? Could be and or. So when we have this flow of information, when we have a trigger, let's just keep using Zapier as the example, because Zapier's, I love Zapier. They do a lot of good stuff. I think Make, previously known as Integromat, I have no idea how to say that. That's why they renamed themselves to Make. They're also very powerful. And so we have this trigger, the event that makes it happen. There's so many fetching kinds of events, right? Could be, hey, it's 12 p.m. Let's send out an email. Data was created. Right? We alerted the people. Hey, someone just input their email and name into my website. Let's send them an email and let's store their email in our email list. Data creation? Not so much data manipulation, but a little bit of it, because you took the information from the event and you manipulated it to store in some kind of database, right? So that's a very simplistic system. When I was working on global supply chain management systems and factory management systems where people were creating or managing their entire production floor, there was so many events and so much data to track. And all of it, we had to fit it into a system, right? Humans are not very good in general at sticking to the same system. James Clear said, "We fall to the level of our systems. We don't rise to the level of our aspirations." And I personally love that quote because, computers are literally designed to execute systems. And let's define system, right? Seeking clarity, defining vocabulary. Getting real meta here, but what does system mean? And for me, I see a system as a step-by-step process that creates a predictable result, predictable outcome, right? And so computers, again, are experts, are designed to execute systems. Step-by-step processes that yield a particular result, a predictable result. And our goal then, as a developer, we're building the system into the computer, into the code. And we have to get so granular with it that every single line is doing another step in the system. If you get down to the most granular basis of it, you are designing every single function that you write is a system. It's a step, literally step-by-step process that yields a hopefully, right, a predictable result. And if it wasn't predictable and it came back with something new every single time, the computer would probably be like, eh. Or your UI might freak out, depending on how strict you needed the response to be. Large language models kind of blow that out of the water because, I mean, they don't give strict responses that are always the same. The results are predictable, but maybe not as predictable as you would want them to be. So depending on your system, your predictableness is going to need to increase or decrease, right? Humans are very unpredictable. Predictable, which makes them fascinating creatures, right? So we defined our system, and systems have a trigger. Something happens, we call the function. Data is created or manipulated in some way. Every single function you write is literally creating or manipulating data. I guess I should also say that it's deleting it, but I'd include that in the data manipulation side of things. And so we have our systems. We have our vocabulary. Now, why are programmers better than you? Because they get fetching good at this. Now, I think my wife just kind of laughed at me over here. So one of the reasons, I mean, I'll just say any engineer really needs to get good at this process. And if they are not good at this process, then they're not generally a super great engineer. Because engineering as a practice requires that we abide by the rules and laws that govern the domain in which we work. And to abide by those rules and laws, we must act with precision. And to act with precision, we must define our vocabulary so that we can understand each of the pieces within our domain well enough to act correctly. Let's take flying, for example. If I'm building an airplane, there are pieces of that airplane that must be built properly. Probably down to, let's say, a couple of millimeters, or the plane will not function properly. And the faster you get, the more laws you need to abide more closely. Like jets, rockets have to be higher in quality, closer to, let's say, perfection in that domain for the rocket or the jet to function at its highest or peak capacity. And we could say that the closer you get to obeying every single law in a domain, the more effective and efficient you will be within that domain. Jets, for example, highly, incredibly well crafted pieces of machinery that if you just bend the frame a tiny bit can no longer function. That's crazy to me. You bend the frame just a little bit. Like cars, I had a 1990 Chevy Suburban, and I got in an accident, and the whole front of the frame shifted over, and I could still drive it just fine. But a jet cannot function if its frame is bent in any way, shape, or form. Or I should say, perhaps it's unsafe to do so, because it could, it's probably going to not act in the way that you would want, because it's no longer obeying the rules of, flight. So, all that to say, in these areas, what makes engineers, programmers, amazing is that they're able to, they have a system for seeking clarity. And, you might, as a developer, programmer, or just random Joe, you might not have a system, and I encourage you to just copy this one. It's I encourage you to always be seeking clarity. Good developers should always be seeking clarity. Always. there's always more to understand about the vocabulary, specifically about the information or data that needs to be tracked and how it's structured. And if we can define this vocabulary, we're able to communicate with each other as humans incredibly well. So many people don't do this and they talk past each other all the fetching time. And I hate it. I hate watching people argue about things, and I'm like, have you guys even taken a moment to like lay the groundwork of what you're actually talking about, what the real problem is, right? Because if you just defined that, if you saw some clarity, I mean, you'd be in a much better spot than you are right now. Next up, they define systems. They define step-by-step processes that yield predictable outcomes. The flow of information. What triggers us? What makes us angry? What data needs to be created? What do we need to say? How do we need to say it? What are the appropriate ways of thinking about a problem? Mental models, frameworks that enable a predictable outcome to this scenario. For example, let's say I'm trying to sell you on something. It's like if I want to sell you on something, there are predictable frameworks, processes that I can use to increase the likelihood of that occurrence. And I, as a developer, with an analytical mindset, engineering mindset, want that. Because there are rules and laws that govern selling somebody on something. And if I can obey them as closely as possible, my efficiency and capacity in that realm will increase. So that's why programmers are better than you. Because they have these internal dialogues of defining vocabulary and defining systems. Now, I'm not going to say that all developers, all programmers, all engineers apply this in every area of their life, but I will say that those who do are a step above the rest because there is so much power in having predictable systems. Even if the system outputs crap, at least you know what it is. You've defined it. You've brought clarity to it so that you can begin iterating on the process and upgrade it to create the outcome you desire, right? I think Toyota was the one who said that your system is perfectly designed for the output that you are getting right now. And if that's true, I mean, the question that I began asking myself is, well, I feel like crap. I haven't gotten anything done in the past day or so. What systems are in place? Habits. I call habits biological autonomous processes, aka like a biological system. They have a predictable outcome. And there's generally some steps involved in the habit. And so, like, what habits have I been expressing that have created the output that I have right now? Go back to the computers. If I'm not getting anything done, it's like, if I'm feeling lost as I'm trying to break down a problem and create a solution for my client, the question is, it's like, have I defined my vocabulary? Have I brought clarity to what I'm actually trying to build, and specifically the information and the structure of that information that I'm trying to track? And if I haven't, I need to go back and I need to do that. I need to. And next up is like, do I know what the flow of that information is? Do I know what triggers the event? Do I know what data needs to be created? Do I know how the data needs to be manipulated? Right? There's all this information that engineers are subconsciously aware of. And if you're an engineer, if you're a programmer and you're watching this, I encourage you to begin taking your internal dialogue when you're on the job, when you're building something that is amazing and you are fascinated by it and you're just breaking the problem down and you're figuring it out. Take that process that you have, because there's the predictable outcome. You solve the problem. That is the predictable outcome of your internal dialogue. Take that and apply it to another area of your life, whether that be health, fitness, mental acuity, sleep, relationships, really big one. I feel like so many people don't have good processes for handling relationships. Again, I was talking about it before, like, so many people don't define the vocab going into the situation, and so the relationship kind of suffers because of that, because the groundwork hasn't been laid. Nobody knows what they're talking about. So define that vocab. And then define the system, the steps that you will take with the other party to arrive at a desired outcome. And that's called negotiation. So, again, this is why programmers are better than you, because they do this internally on the job and thus have training on it and can take that and apply it in any area of their life on a whim, if they want to, if they realize they can. I personally am just now, like, over the past 6 months, have realized that I can and that I need to. And it's actually been really interesting to try and break down how I program things, because I've been doing it since I was like 11 years old. And most of the things that I do, like the processes that I go through internally, are so heavily ingrained in me, so natural at this point, that it's difficult for me to step back and capture when I'm doing them and what I'm doing, so that I can improve upon it. So it's been a little bit, I don't know, frustrating isn't quite the right word, but intriguing to try and capture what I myself do as a developer and bring clarity to it. And this in particular, this defining vocabulary, defining the system, the data to track the flow of information, the trigger, the data creation and data manipulation, these are things that I personally have captured over the past 6 months or so. Boiled them down to, this is what I do. So, I mean, if this has been interesting to you, again, I'm going to start streaming more often. Specifically, I'm going to stream on Twitch and YouTube at the same time using a new software that I got called Restream. Super excited about that. I also got my face in this nice little bubble in the bottom right corner, and that's pretty awesome. Figured out how to do that. I could probably improve on it. And I have this nice new software that'll let me do some flow charting with you guys in real time. And I really love that. I really like flow charting. So this is going to happen more often. I'll be probably streaming 3 to 4 times per week with friends, just building things, building games, building software that I really want. Software called bookending, for example. It's like this idea of bookending. And again, what is bookending? Defining vocab, right? Bookending is, I wrote down a definition. Let me just go and look at my legit definition so that I can just make sure that I'm giving you precisely what I want you to receive. Bookending. Yeah, so bookending is the process of tying the beginning of your task or period of time to the end. The goal is to build the entire narrative. It's like, I want you to comprehend, or to set your intention at the beginning of the task or time period, the beginning of the day, right before you hop into that programming session. Define the intention. What are you trying to accomplish in the next hour, in the next day, the next week? Find that intention. And then at the end of that time period, or that activity, that task, you go back and review, like, did I stick to my intention? Did I tackle the things that needed to be tackled that I told myself I would do at the beginning of this week? Did I actually do them? So that's bookending. I'm going to be working on that with Amir, and I'm super excited about that. I am super excited to see other people try it, because I know it's already been so fetching beneficial to me. So let's do this, gents. Let's make programmers out of everybody, because we know we're better than you.